Okay, so today we're going to talk about alternating series. Alternating series are really easy. Well, I find it easy at least. So I'll explain a little bit and see how it goes. In order for an alternating series, basically must conform two rules, which number one has to be the b sub n plus 1 has to be less than or equal to the b sub n. And number two, the limit as n goes to infinity, b sub n has to equal 0. So in order for us to test this, let's use an example. So for example, let's say we have the series of n equals 1 to infinity of negative 1 n plus 1 over n plus 2 factorial. So now our b sub n would be 1 over n plus 2 factorial. And well, I like plugging in numbers first. So if you plug in, let's say 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, 1 over 4 factorial, and so on and so forth, we see that this fraction, even though we're using factorials, it's actually, the denominator is getting smaller and smaller. So this confirms the first series, the first test, meaning that b sub n is going to be smaller than b sub n of plus 1. But now we could also see it with the limit test. So if we do the limit test from limit of n to infinity of 1 over n plus 2 factorial, we see that if we plug in numbers, right, we're going to get a really big number. So for example, let's say 1 over, 8 plus 2 factorial. We're going to get a pretty big number. I'm not sure what the number is, but we're going to get a pretty big number. But as this gets bigger, the fraction itself is decreasing. Therefore, this fraction is getting closer and closer to 0. So the limit as n approaches infinity of 1 over n plus 2 factorial is equal to 0. Therefore, the first and the second rule are confirmed. Now, we could use another example of, let's say, n equals 1 to infinity of negative 1 n over times 1 over n. So now, basically, we're going to do a limit comparison test. No, a comparison test, basically. So we'll see if 1 of n plus 1 is less than or equal to 1 over n. Right? So basically, this is going to get smaller and smaller. Right? And that's going to make this smaller than the original sub n, confirming to the first rule. So for example, let's say you have 1 over 4 plus 1, right, which will be equal to 1/5. And then we have 1/4. Obviously 1/5 is smaller than 1/4. So therefore the first rule is confirmed. Now we do the limit test again to see if as n reaches infinity of b sub n, which in this case would be 1 over n, right? But we know this limit. Once we see this limit, we automatically know that this goes to 0, no matter what, regardless. So this obviously is confirming the second rule. So okay, now so both of these, we call these convergent. Oh, this sucks. So both of these are converging because they converge to a finite number. So we get a 0 and a 0. Now, let's do an example where it diverges. So, for example, let's say we have n equals 1 to infinity of -1 sub n, well, raised to the n times n over 5n plus 6. Now, we could do the same thing, follow the same steps as the first example. Let's label these. And our b sub n will be n over 5n plus 6. Right? Now, for this we could use kind of like the ratio test. Well, not the ratio test, but if we look at the degree on the numerator and the degree on the denominator, they're both the same, right? So we could use the coefficients as the ratio. So in this case, since n, so this is n raised to the first and this is n raised to the first. Since these are equal, then we use the ratio, and obviously we have, so then our ratio would be 1/5, right? 1/5 is definitely not equal to 0, so therefore it diverges. Remember, you must have your limit. Your limit has to be equal to 0. It can't be anything but 0. So if you have another number that's 4, 5, whatever, it's gonna diverge no matter what. Okay, and yeah, so that's some examples. If you hope it's kind of clear for you. If you don't understand, then I know it's kind of tricky, but it's not that hard once you start practicing it a little bit more.